Have you ever wondered what happens when a star dies? Imagine a giant cosmic vacuum cleaner so strong that not even light can escape its grasp. That, my friends, is a black hole. Black holes are regions in space where gravity is incredibly powerful. They form when massive stars collapse at the end of their lives. Imagine squeezing the entire mass of the sun into a space smaller than a city. This immense density creates a gravitational pull so strong that nothing, not even light, can escape. That's why we call them black holes. They don't emit any light that we can see. But don't worry, these cosmic vacuum cleaners are far, far away and pose no threat to our planet. They are fascinating objects that help us understand the universe better. Imagine approaching a black hole in a spaceship. As you get closer, you'd notice something strange, a boundary in space known as the event horizon. This is the point of no return. Think of the event horizon as a cosmic trapdoor. Once you cross it, there's no coming back. The gravitational pull becomes so strong that even if you were traveling at the speed of light, you couldn't escape. It's important to remember that the event horizon itself isn't a physical barrier. It's simply a region in space where gravity's pull becomes inescapable. Now, let's talk about what happens if you were to fall into a black hole. It wouldn't be a pleasant experience, to say the least. As you approach the black hole, the gravitational pull on your feet would be much stronger than on your head. This difference in gravity would stretch you out like spaghetti, a process aptly named spaghettification. Don't worry, you wouldn't feel any pain. The stretching would happen so quickly that you wouldn't even have time to notice. Spaghettification is a consequence of the extreme tidal forces near a black hole. It's a fascinating example of how gravity can warp and distort space and time. Section 4. Time warps and frozen clocks, time dilation at play. One of the most mind-boggling aspects of black holes is their effect on time. Time behaves very differently near these gravitational giants. As you get closer to a black hole, time actually slows down. Imagine you have a friend watching you fall into a black hole from a safe distance. From their perspective, they would see your clock ticking slower and slower until it appears to stop completely at the event horizon. However, from your perspective, time would continue to flow normally. You wouldn't notice any difference in the passage of time as you fell into the black hole. Section 5. Beyond the singularity, mysteries of the unknown. At the center of every black hole lies a point of infinite density called the singularity. This is where all the matter that falls into the black hole gets crushed into an infinitesimally small point. What happens at the singularity is a complete mystery. Our current laws of physics break down at this point, and we don't have a complete understanding of what goes on inside. Some theories suggest that the singularity could be a portal to another universe or a different point in time. However, these are just speculations, and we need more information to unravel the enigma of the singularity.